We have something very special. I'm a big fan of nuclear technologies and SMRs, and despite having lived nearby a nuclear reactor myself, I still think that they're pretty awesome. And last fall, Google and Kairos Power embarked on an extraordinary journey to develop and deliver upwards of 500 megawatts using advanced small modular reactors, SMRs. And it's a technology that's poised to redefine strategies for hyperscalers, data center operators, and today we're gonna get a chance to talk about it. We're gonna talk about nuclear energy's impact. We're gonna talk about how this is supporting AI's power-hungry demands, the role of advanced reactors in stabilizing grid architecture, and how data center operators can certainly advance and adapt and evolve to this extraordinary energy landscape. So with a big round of applause, get your learning hats on, because we're gonna be studying some of this stuff. Please welcome to the stage Lucia Tian, Head of Clean Energy and Decarbonization Technology with Google, and Jeff Olson, Vice President of Business Development and Finance with Kairos Power. Coming up. It's so good to see you. It doesn't matter. Anywhere you like. Hey, Jeff, it's good to see you. Please. We get the best intro music. It's just calm and gets everyone nice and ready. I really am excited. Not that I'm not generally excited, in case you can't tell, but this conversation I've been so looking forward to. We're standing at a crossroads right now of unprecedented demand and an absolutely urgent need for clean, scalable power solutions. With the explosive growth of AI and hyperscale computing, if I'm not mistaken, we've got about 5 gigawatts under construction today, with another 35 gigawatts in demand, plus actually even more than that by 2030. It's an extraordinary amount. Our industry is now facing an imperative where we must embrace innovative and reliable clean energy solutions. Now, October 2024 was a very special day. It's the day that you embarked on an extraordinary journey, a groundbreaking collaboration to deploy those 500 megawatts using advanced small modular reactors, or SMRs. And I'm excited that today we have this extraordinary opportunity to dive into those details, discuss this partnership, and sort of explore what this means for the future of data centers and clean energy. You've heard me say this before. I have a little saying. You need 2 things to be successful in the industry right now. You need power, and you need bravery. And although Wade yesterday had his own little take on it. But we're going to be talking about both of those aspects today. And again, joining me, again, thank you, Lucia and Jeff. I think we're gonna just dive right into this conversation. Lucia, let's set the stage. Let's set the stage with you. We'll let you go first. And this is kind of a more of a 2-part question. What led Google to explore nuclear energy? And this is where I'm super curious. Why small modular reactors? And specifically for your role at Google, how does this align with your broader sustainability and decarbonization strategy?
Well, thank you. First, thank you, Bill, for having us, and lovely to be here with you all this morning to chat about this exciting partnership with our partners at Kairos. Maybe I'll set the stage first with the big picture, right? Why nuclear? Well, as a clean, firm power generation resource, we see nuclear, along with a whole suite of other advanced electricity technologies like next-gen geothermal and long-duration energy storage, as a critical part of the grid of the future, a clean and reliable and affordable grid. So that's the big picture reason for nuclear, right? Google has a goal to run on 24/7 carbon-free energy at all of our data centers and offices around the globe. So what does that mean? That means we try to match our electricity demand on an hour-by-hour basis with new clean energy resources that we bring online in the grids in which we operate. And so that's a pretty tough puzzle to solve, right? And we've been historically have long been a large one of the largest non-utility purchasers of clean electricity from traditional renewables like solar and wind. But as we took on this 24/7 CFE goal, which is much more ambitious, we realized that we really need that portfolio of technologies. And we actually do a lot of our own internal optimization modeling around how we get to our goal, right, in the most economic way possible. And what we've realized is it's actually much more cost effective if you are able to bring this portfolio of technologies rather than just a few mature ones. So that's the reason we're investing in this space through our offtake and other mechanisms. Now getting to the second part of your question on, why SMRs and why advanced nuclear. Well, I think first I want to clarify and say, we are, just like in the broader technology landscape, we're in all of the above strategy. On nuclear, we are also in all of the above strategy. So we do think we need to also work on things like restarts and license extensions and uprates for the existing nuclear fleet, as well as building new nuclear, right? Let's maximize what we have, and then also let's build the new. And in that new category, we support building large nuclear reactors and small. But there are reasons why we're really excited about advanced reactor technologies, and particularly our partnership with Kairos. So for example, the small modular reactors open us up to more siting options. We also really love the way that Kairos is, and I should let Jeff really talk about the technology, but we love how they are approaching building SMRs, their iterative development approach that allows us to see sort of de-risking and cost downs along the way that give us, as the customer, more certainty around cost and ultimately leads to a faster deployment timeline. But
I think you just T-ball, like that softball question right there. So thank you. And that, Jeff, this goes back to you. So this group of brilliant human beings that I can barely see because of these lights, but there's a whole lot of people watching over there on the live stream as well. Hey, folks. This is where we get to visual learners. These are visual learners here and, of course, abroad. So I think you've got your clicker with you. But this is where it gets kind of fun. We're going to put our engineering hats on a little bit at least. But can you walk us through some of these technologies behind Kairos Power? And really, this is where I'm super curious, and everybody else, what makes your solution particularly interesting and suitable for data center applications?
Yeah, will do. So I'll put the slides up in a second here. I think just to respond to some of the points that Lucia brought up and to answer your initial question on partner selection and where we began the journey, I think it's important for Kairos as we looked for our first commercial partner as one that would be a committed catalyst to enabling advanced reactor technology and generation to come online. And looking for that long-term vision and commitment that Google has brought to bear, and really the true spirit of collaboration that not only it began before October, but has only grown since, as you pointed out. And I think that commitment to enabling new energy technologies only demonstrated yet again by the recent announcement yesterday in the data center, in the geothermal announcement that you all had. So I think that's yet another proven commitment there. With regard to the technology that Kairos Power is bringing to bear, Kairos Power is singularly focused on the development and commercialization of our fluoride salt-cooled high-temperature reactor. And what that means, we're developing a 150 megawatt increment power plant solution. And we're doing so leveraging technology that both universities and the DOE have decades of experience with. And that includes TRISO fuel, which has been dubbed by the DOE as the most robust nuclear fuel on Earth. Wow. And FLIBE, which is a molten salt coolant. We're the only ones combining that technology. And our ability to do so allows us to deliver a technology that has robust safety, but also is able to operate at near atmospheric pressure. It takes away a lot of that very expensive and higher risk construction of high pressure containment systems. What we're doing, the what of the technology matters very much, but as important is the how. And so here we'll bring up some of these slides, and don't worry, they're only a few. I know it's early, and this can put us to sleep easily if they're not focused, and they will be. So these are largely pictures that we're going to look at. But this is Kairos Power's iterative development approach, and Lucia mentioned this. This has proven to be important, I think, in the early days of our connection with Google, but also with others who are looking at Kairos, like utilities and other data center developers. Because what Kairos is actively doing right now is we're building today. So there's an active engagement in design, construction, operation, and then decommissioning, because in this industry, in the nuclear industry, you have the responsibility to decommission. And so what we have are a series of increasingly prototypic to our ultimate commercial deployment systems. So these are large at-scale systems. The series that you see at the bottom up on screen here are engineering test units, ETU. I'll show you some photographs of these in a moment, but ETU-1 is something that we've designed, built, operated, and fully decommissioned. And that happened in Albuquerque, and that was a stick build, so we built that from the ground up. ETU-2 will be based on ETU-1, but that's a modular-based build, and I'll show a few photos of that. We're about halfway through the ETU-2 build now, also in Albuquerque, New Mexico. ETU-3 will be placed in Tennessee, on the same site where we are now building our first reactor. So building in one location in Albuquerque is one thing, and that's very, very important in doing repetition there. But being able to do that in another location with different geotechnical challenges, different labor considerations, those things matter. And so that's why we have that last iteration there. Then we move into our Hermes nuclear reactors, then we move into our nuclear systems, and then we scale up through KPX to get to the commercial deployment that we'll deliver with Google. What that looks like tangibly and in practice is this. So the large photo that you see there, that's the engineering test unit. We built and ran that fully and successfully, and there were lessons learned along the way. Did it go exactly on schedule? No, it did not, but that's the point of iterative development. We learned from there, for example, how long it takes to melt FLiBe. It takes a long time. There's a lot of thermal inertia. That's valuable, but you need to put that in your schedule. We know that now, not on Google's time or their dime, but on ours. And then you see us decommissioning. Again, part of the process with nuclear, but an important part to learning and to be able to look at these systems. That was our stick build. This is now our modular build. So we hear a lot about this. We see a lot of pictures, and speaking of modularity, but this is what it looks like in practice. And there will be over 20 of these modules that will come together to build that system that we saw. And then lastly, this is what it looks like to break ground in Tennessee. So the other two photographs were in Albuquerque. This is in Oak Ridge, Tennessee, and this is where we've broken ground for both our engineering test unit number 3, so continuing forward progress there, and then our Hermes reactor. So a few photos to show what building looks like and how we are iterating and why that's important to Kairos.
That is so neat. I'm a visual learner as well, so seeing some of this stuff in action is incredible. All right, so let's do this we're both panelists, but Lucy, let's go with you first. I might get some shade from this, but I do believe that like collaboration at this scale between a tech giant and energy innovators is not common. It doesn't always happen. There's a saying in the data center industry that the data center industry loves innovation as long as it's 10 years old. Right? You blink and then it feels like 10 hours go by right now. But could you share the story behind your partnership? How did Google and Kairos Power first connect, and certainly what made this collaboration very successful, Lucia?
Yeah, and it's funny that you say that, the sort of 10-year lag saying, because I really think about data centers as the digital infrastructure that enables incredible innovation, right? And I think in the energy space too, we can be truly catalytic to advance clean energy technologies. So I want to push back on that a little bit.
Good. Let's throw that term away.
Because as Jeff mentioned, right, this is not the only partnership, right? We are really trying to catalyze clean energy technologies around the globe and across a full range of technologies. I think Jeff alluded to this. Just a day ago, we launched a partnership with Baseload Capital to bring new geothermal power to Taiwan, a region that is very sort of clean energy constrained, right, the Asia Pacific region. We're excited about that partnership, and it builds on our earlier work in geothermal right here in the US, right? We were the first off-takers from a small pilot facility with Fervo, and once we showed that that was working, we scaled up last year to 115 megawatt offtake from Fervo in Nevada via our utility there, NV Energy. And so it's sort of a pattern for us of, hey, how can we be building these catalytic partnerships in order to bring this portfolio of advanced clean energy technologies online? So I hope this is, if it is rare, then we're making it less rare to build these innovative partnerships. That said, I think what the common thread is, and I think some of I imagine Jeff will reflect this too, but the journey to get here takes a while, right? It certainly goes back well before October and requires a lot of close partnerships over many months to get to a place where we can share something with the world, and it doesn't end here. Now we've actually got to build the thing.
Yeah,
I agree. Let's keep those partnerships going.
Oh.
Jeff, comment?
absolutely. Yeah, everybody wants 10 years, right? Even in the innovative space, if you have 10 years, that's a benefit to have, but you have to be cutting edge at the same time. As you can imagine, for us in our earliest days, thinking about what the commercial landscape looked like almost 10 years ago now when we started, probably not too surprising, it seemed that utilities might be the first customers. And if you want to talk about somebody that has to have a conservative position, because we all like our lights to turn on when we hit the switch, and if they don't turn on in about 5 seconds more than once a year, we have a big problem, right? So understand, and that stakeholder group is still important to us. And we understand with data centers, you need your electricity. You need to know that your source of generation will be there. That's not missed on us. Thankfully, the technology that we're working with already has decades of experience with its origins in the 60s and 70s with the molten salt reactor experiment and TRISO fuel with international labs. So that's good. We simply get to combine it in a novel way, but that is novel. So through the iterative process that we went through and the journey that we've gone on, for example, here now with Google, we were able to not only talk about things and show PowerPoint and CAD, but walk through our manufacturing development campus in Albuquerque to actually see what we're building and speak to the operators who are operating the systems that are at scale and at temperature now. And I think that's been a very important part of the process based on how I saw things going with Google, but also how we've seen things going with utilities and others in the space.
Oh, that's wonderful. I want to see more of these partnerships happening, and hearing you both discuss this is very invigorating. But we're gonna shift a little bit here, Lucy. I want to start with you because I know that this is on everyone's mind, and Jeff, I'll let you sort of noodle on this for a second. But adopting nuclear technologies often comes with some public perception challenges. I'm very curious how is Google navigating these hurdles, and honestly, what can other hyperscalers as well as all the folks in this room and data center operators learn from your experience? And Jeff, I'd love to hear your thoughts about this as well. But Lucia.
Yeah, I'm glad you bring up public perception because I think this is actually an incredible story over the last couple of years right here in the US, right? Support for new nuclear deployment and sort of nuclear power overall has surged in this country over the last couple of years, and it's really been across the political spectrum.
Yes.
And so I think that's very exciting. That gives us a moment where we can really advance rapidly the deployment of nuclear. And I think I really see that as an exciting opportunity. That said, that is not even across the globe, right? There are definitely countries that are more or less accepting of nuclear technologies. And I think we always have to be sensitive as a global company to the preferences and needs of specific communities around the world. That said, I would say, and Jeff probably has more experience with this, right? The communities where there is nuclear operating are incredibly supportive of nuclear as a technology. What I would say is perhaps the bigger hurdle or the bigger challenge that we face is that every time we bring one of these projects to bear, there are many stakeholders that have to be part of that, right? It's not just Jeff and Lucia, it's not just Kairos and Google, right? A utility, for example, has to be a big part of that picture because for the most part, especially in these early deployments, we're expecting these to be grid-connected assets, right, that are serving our data centers. And that means we have to sometimes innovate not only on the technology, but also on the market mechanism by which we're actually bringing the resource online. So just as an example, in the last couple of years, Google has been working hard behind the scenes with our utility partners on something we call a clean transition tariff, or CTT. And what that means is it gives us a new market tool that allows us to bring online things like advanced clean firm technologies faster in a utility territory, while not burdening the premium of that deployment on the ratepayer. So we've actually put that into practice in Nevada with our partnership with Fervo and NV Energy, and hope to bring that elsewhere with Kairos and others.
Yeah,
That's very helpful. Jeff, any hurdles and challenges you can talk about?
yes, but also yes, I very much agree with what Lucia said, and let's start with the communities, and then I'll talk about something else that matters as well. But there has been a lot of momentum within the U.S. For nuclear energy across all fronts, from multiple different stakeholders, both sides of the aisle. I think it's been just an overwhelmingly supported technology. It provides baseload, it provides reliability, and we as a country have a strong history that we can build upon and increase our energy security. So I think all of that is great, but the local community matters too, right? We all live somewhere, and that matters to us. I think the support that we've seen, that Kairos Power has seen with the local communities, has been very strong, as Lucia pointed out. And I think it is a technology that requires a lot of education. There's a lot to understand about the technology, about the licensing. It's just not something that a lot of us have a lot of day-to-day experience with, and we only have 15 seconds to learn about new things between what we have to do, from waking up to going to bed at night. But what we found is the communities that do have experience with our existing operating fleet within the United States are very well educated, very supportive, and are welcoming to Kairos and other developers. There are other SMR developers that are doing well out there also. And that's been very important, but that's not also been without an investment, right? Yeah. A big investment from Kairos going out, explaining, opening our doors. But that's been demonstrated not only in how we've been received, but also how well our construction permitting has gone with the NRC and the local support that we've had in that process and the success that we've had in getting our construction permits for our first 3 reactors. In terms of, so looking at another aspect of real challenges that we need to take head on, and that's delivery, confidence in delivery, and confidence in cost, or as we say, driving towards delivery and cost certainty. Now, I like to say driving towards. It will be a never-ending journey. We don't know what's going to happen in 30 seconds, let alone 5, 10 years down the road. Let's be real. But in order to address that, again, it's our focus on iterative development, working with our teams to build now, take the lessons learned from each one of those iterations and apply them. And another aspect that I haven't spent as much time talking about yet is Kairos is also highly vertically integrated. So we are doing our own licensing, which has been successful with the NRC for our first 3 reactors. Oh. But when Google came to visit, when utilities and others come to visit, they also get to see us in New Mexico manufacturing and fabricating our own graphite blocks. We are fabricating, not enriching, there's a difference, not enriching the fuel, but we are fabricating the TRISO fuel pebbles, and as well as our vessel. A number of the components critical to our nuclear island, we're doing vertical integration on that front as well, and doing that in repetition with little loops in between the big loops that I showed you within those iterations to de-risk cost and delivery, and that is very important. And so far, it's proven to carry us down the path that we need to be on right now.
That's wonderful. I'm really pleased to hear that there's so much collaboration and investment happening to educate the market, and that this is, my gosh, it's accelerating. We're seeing this. We're seeing this happen. Jeff, I want to stay with you here for just a second. You mentioned some of the support and investment and collaboration you've been working with. The U.S. Department of Energy's Advanced Reactor Demonstration Program is backing the design and construction of Kairos Power first reactor through a cost-sharing agreement with the company. I'm curious about this. Can you explain how the government support has influenced your timelines, your objectives, and your strategy for scaling the deployment?
Yeah, absolutely. So the Advanced Reactor Demonstration Program through the DOE was an award that we had received almost 5 years ago now, give or take. And it is a cost share program, but we approached it in a unique way. And rather than simply looking at time and expense reimbursement, now oversimplifying for those of you that are in depth in government funding, just given the time that we have. But what we're doing is we're doing a milestone-based approach. And what's novel about that is we don't get paid until we deliver objectively identified milestones with the DOE. So it does motivate us to be efficient and effective with our own resources. And then once we demonstrate objective milestones and delivery, then and only then do we get paid by the government for the work that we've done. And that is, it took a little bit longer to negotiate that than had we accepted standard terms. But it's an approach based on success that the government's had elsewhere, like the NASA COTS program. There are some similarities there. And it complements the existing investment that we have well. But through that negotiation process, we didn't miss a beat. We kept going and picked up where we left off, and we accepted that. It's about a $300 million award from the DOE. Yep.
Oh, it's good to have that kind of support. That's awesome, Jeff.
Yeah.
Lucy, I'm curious from your perspective, let's go into operations for a little bit. From an operational perspective, how will integrating SMRs affect the reliability and stability of Google's data center strategy, data centers energy infrastructure, I should say, and what considerations as you deploy all this are you preparing for?
Yeah. Well, first I should say, I think part of going back to the public perception question, right?
Sure,
like
please.
part of the growing support for nuclear is recognition that as a baseload, as a clean, firm sort of baseload technology, nuclear is incredibly important for the reliability of our grid. And from the data center perspective, that baseload profile also very nicely matches our largely flat load profile, right? That said, the important thing to note that I've already alluded to earlier is when we first bring these first deployments on, we are not intending for these to be behind the meter resources, right? We intend, even if they're co-located, we intend for these to be grid connected and to be served through the grid. And I think that will keep going for a little while, and I think in the long term, very much open to considerations of what a behind the meter solution might look like. But for now, I think from an operational perspective, nothing needs to change.
Okay, well, that makes a lot of sense. This is an important one because obviously time to market is critical, Jeff, but also scalability. So this is where we're going to go with this one. For hyperscalers especially, right, but also for co-location providers, scalability is key. Right? That's one of the things they always think about. How can I grow in a market? What are some of the critical factors for realistic scale when working with SMR technologies?
Yeah, it's important. We thought we were doing pretty well when our plant size was 150 megawatts and we'd be ready for data centers, and now you all are going to gigawatt capacity. So we're doing what we can do to keep up with this industry. But what we've come to find, a few things. One, the solution that Kairos Power is deploying has a lot of benefits in its scalability and what it is. It's a 150 megawatt power plant for each single plant, right? But with that, we can deploy a small number of plants to get to a gigawatt, right? And we have something that I think your industry, and when I say you, I look to you as an entire room, is generally familiar with in having redundancy in generation. So not too different than, for example, a number of diesel gensets side by side and having redundancy there, you'll have redundancy in power plants. So the ability to scale in that capacity without having to change our technology or plant configuration is helpful. Two, as we scale at a site, there's a couple things. One, we can grow with the data center. As computing needs grow, whether that's behind the meter or more likely in the nearer term, adjacent or nearby, we can continue to expand that capacity, working with the off-taker and the utility to scale accordingly. But also when we do that at a single site, we see economies of scale easily. Especially when we have long-term committed partners like Google, and we can look at sites and say, listen, the long-term vision of this site is approximately X 100 megawatts, and we can plan the program accordingly. Very scalable. But all that comes through our ability to have cost and delivery confidence. So again, everything we've been saying through this whole presentation, those iterations and understanding how to do what you're doing through that vertical commitment, really important.
I'm going to throw a little curveball here because we've got a couple extra seconds. I asked the question, scalability is key for hyperscalers, and I'm sitting next to one right now. Can I ask you this, right? Obviously, you've got this wonderful partnership here. How are these technologies impacting Google's plans and strategies to scale, potentially using SMRs?
Yeah, and I think, again, I'll go back to maybe two points. One is this fits into a portfolio, right? And in a portfolio, we need a whole range of different technologies, including variable renewable technologies, but then you need a certain amount of base load in there. And so having these different options and Lego building blocks to put together for any particular data center site is really important. I think the second thing is this scalability. In the nuclear industry, a word that has become very, very frequently used is the word order book. Right? And I think what's important about that word is it is about a fleet deployment approach. One of the big challenges in the US nuclear industry is, I think, a lack of faith in the ability to actually construct on time and on budget because of some of the recent experiences we've had in the US with Plant Vogtle, right? And that's partly driven by the fact that in the US, the current nuclear fleet is a real patchwork of different designs and different variations on different reactors. And what we really need is a design that we copy, paste, copy, paste, copy, paste. And the more we do that, the more cost certainty we get and the more cost downs we drive. And so I think for us, part of the exciting thing about this partnership with Kairos is the ability to say, okay, let's actually work together on this order book of 500 megawatts so that we give Kairos the runway to that scale to actually demonstrate those cost downs and for us to benefit from that.
It's a rising tide situation, right? Yeah. We're floating quite a few boats here. We have just a couple of questions left, and I think these are really important. You know, oftentimes on these keynote panels, I'm like, let's look into a crystal ball. We're looking into it. This is the crystal ball. This is the future that we've been talking about for so long, and it's here right now. I'm curious from both of you, and Jeff, let's start here. There's a lot of very curious minds in this room. There's a lot of people curious about these technologies. In fact, on the expo floor, there were a bunch of booths and stuff promoting nuclear SMR or availability to nuclear technologies. Jeff, I'll start with you. For organizations, which I have no doubt are considering similar pathways, what's your best advice for getting started? And ultimately, you know, if there's an early stage, what is an early stage consideration that's most critical?
Yeah, so there might be two ways to answer that. If you're an organization looking to offtake nuclear energy, or if you're an organization like Kairos looking to bring some new hard tech to market, which could be a form of energy. I'll try to be brief and answer them both. One, if you're an organization looking to offtake, or be a part of the equation as a financier, or whatever it might be, engage early. There's a lot to learn about the space, and there are a lot of misconceptions out there. For example, licensing. This isn't a licensing panel, although we could host one with some of my colleagues, and they're the best of the best. But there are a lot of misconceptions about licensing out there. The NRC is impossible. The industry will never get through. We have 3 construction permits from the NRC. Wow. 3 of 4 that exist, but we've applied, we've gone through the process, and we've made a real investment. It's possible. There are a number of other questions and conceptions, some of them right on and some of them not, but I think engage early with folks like Kairos or others in the space and learn from that and begin to understand how real advanced nuclear is and how we all may be able to work with you. If you're a company that's like Kairos and you're bringing something new to market, or even some other form of hard tech, the best advice that I can give, and this is my 3rd early stage energy company that I've had the opportunity in my career to be a part of, and what I think is working so well for us, and this is real large hard tech in every aspect of that definition. And to some of you this may be obvious, but don't just think about the technology and what you need to do, but how you need to go about doing it. Our how is the iterative approach. Our how is very selective vertical integration, but it's mapping that pathway out and understanding that that doesn't only apply to the technology, but also to our licensing approach, to managing and de-risking supply chain, and also to our commercial approach. And as we've mapped that path out through those iterations and with that strategy, with that delivery end in mind and what we need to de-risk, that's been really important and helpful for us on that front.
Oh, that's awesome. Very cool. Thank you.
Yeah.
Lucia, what do you think?
Yeah, I think maybe the first thing I'll say is, as sitting in the off-taker seat and sitting in the sort of hyperscaler data center seat, is we need to, even as there's this sort of frenzy and this day-to-day sort of acceleration of timelines, we need to take a slightly longer view, right? And I've talked already a lot about this portfolio of technologies, but I think we can't just look at what can we deploy tomorrow? What can we deploy in 2026, 2027? Because as we look out, energy infrastructure takes time to build. And even some of the technologies that we think are mature today and are normally fast to deploy, right? We're seeing turbine slots for gas, right, go out to 2030 already, right? And costs rising across the board. So once you're in that situation, actually you got to start thinking about, okay, what is the optimal portfolio, and does that bring into the picture some technologies that might be perceived as farther off, like nuclear. So that's maybe the first thing. And then I think the second thing is some variation on what Jeff said, which is, get involved early. I think for us, what was really important is to really understand the risks involved in an earlier stage technology, and also how the process and timeline of how those risks get retired in the development process. And that gives us confidence, that gives us an understanding of what milestones to look for, and that also allows you to work closely with a partner and understand each other's needs, and ultimately be able to solve for those risks jointly.
I'd love to get a couple of just final closing thoughts as we wrap up. We've learned so much. I think everyone in this room is probably going to go home and start looking up SMRs and nuclear technologies. How do I put this in not my backyard at least, but certainly in a facility where I'm going to run and manage this. I'm excited. In case you can't tell again, I think these technologies are extraordinary. Jeff, let's start with you. Really just some final closing thoughts to inspire this audience to go out there and not be afraid, but embrace these technologies.
Yeah, I would say this audience has been an inspiration for our industry, the advanced nuclear industry, and Google and Lucia, you and your team have been a huge part of this. But everyone in this room is part of a massive movement right now that it's not new. Data centers have been critical to what we all do, what you've got in your hand right now, for much of our professional lives. But the momentum that's being carried right now with AI and driving the need for energy, yes, it's creating a demand that the market doesn't know how to deliver right now. And quite frankly, we're not 20 years out, but we are a few years out before we can even deliver on that. But what this group and the data center industry is helping to do, like space has done in other industries, is to catalyze new energy technologies, right? Increasing the portfolio, all of the above approach that the US is embracing across multiple fronts right now. There are few, if any, front runners having a bigger impact than the folks that, or the industries that you all represent, the industry that you all represent is having right now. So I think, not just with us, but others that are driving new forms of energy technology to address the needs that you're going to have. And working with your utilities to understand the importance for them to think about new technologies and new approaches to deliver. I think, that's probably what I can say. And a big thank you, one, Bill, for inviting us to be here, but to everyone in the room, and especially to Google, for being willing to begin to take those steps to think about what's next. And I do see the additional and incremental benefits to other industries being very significant, given the work and the steps that this group is taking.
Oh, that's perfect, Jeff. Lucia, any final closing thoughts?
Well, I think Jeff already said it all, but we really are on the cusp of I think, new era of AI-driven innovation and growth, and we need this kind of innovative thinking in the energy infrastructure space in order to power that. So that's the exciting moment we're in, and I would say we need more partners. We need more stakeholders at that table to make it happen. So I think that's my challenge to all of you.
Oh my gosh! As we've heard today, and this is my big takeaway, I believe that innovation is much more than just technology. It's about courageous collaboration. There's that bravery thing I was talking about, and the daring to rethink what's possible. And I believe, based on what we've talked about, that's my challenge to the group: is to dare to rethink what's possible. Look at these new technologies and don't be afraid to adopt them. Jeff, Lucia, thank you so much for joining us today. This was extremely insightful. And thank you, everybody. This was awesome.
Thank you.
Thank you so much.
Thank you so much.
Lucia, that was awesome. Jeff, thank you so much.